Imagine having a data set where two groups look identical in every feature except one. How do you draw the perfect line between them? Today, we dive deep into linear discriminant analysis, the statistical powerhouse designed specifically to maximize that separation. Linear discriminant analysis, or LDA, is a supervised dimensionality reduction technique. Unlike other methods that just reduce noise, LDA's sole mission is to find a linear combination of features that characterizes and separates two or more classes of objects effectively. So how does it actually work? LDA operates by finding specific directions in your feature space. It calculates a new axis that maximizes the difference between the class means while simultaneously minimizing the spread or variance within each individual class. Visually, think of it as projecting your x and y data points onto a single new axis. This projection stretches the distance between the center of one group and the other, effectively reducing overlap and making classification boundaries much clearer for your model. The power of LDA lies in its ability to not just reduce complexity, but highlight the key features driving separation. Because it is supervised, it uses class labels to identify which variables are most important for distinguishing failures or categories in production systems. However, there is a critical limitation you must know. If the class distributions share exactly the same mean, LDA cannot find a separating axis. In those specific cases where means are identical, you must switch to nonlinear discriminant analysis for results. In summary, LDA is a generalization of Fisher's linear discriminant that creates the most distinct groups possible by optimizing the ratio of between-class to within-class variance. It transforms messy data into clear, actionable categories. Now that you understand how LDA categories maximizes separation, consider this. When should you choose LDA over PCA for your next project? Let me know your thoughts in the comments below.